All right, we're going to do the exam 2 review this morning. This will be the last video that I make for a while. In week 4, you'll watch videos on YouTube that were made by some different channels, and it'll be over things like the history of computing and big data. I think maybe some security, different topics like that. So you'll get a little break from my voice. I'm going to share my screen and go through the topic list. You can find this in D2L under week 3. So exam 2 is this Thursday, and that is July 21st. So that's exam 2. And then all of next week, you'll have the YouTube videos. And then the slides for your student presentation were originally due this Sunday. And I believe I'm going to push those back to be due, instead of it being due Sunday the 24th, I think I'm going to push those back to being due on the 31st. And that way this week you can focus on exam 2. I think you'll have a little bit more time next week to work on those slides, since you won't have any programming assignments to do next week. I think it's 3 quizzes and then like the social media assignment, if I remember correctly. So I'm going to push that back to, I'm going to push the presentation deadline back to the next Sunday. And then class is over, right? Because this right here is the last week, and all you will have to do is take exam 3 and do your videos of you going through the slides and presenting what you found to the class. So there is a light at the end of the tunnel, right? We're almost there, over halfway at this point. Okay. So here, this entire exam is over Python. It's nothing but Python. So make sure that you know how to write comments and how to do different print statements, and especially like combining multiple things in a print statement. We've done a couple of examples of that now, where you've had, some kind of like text that you printed out that's always the same. And then you can combine that with a value that's inside of a variable that can change, depending on different input or different calculations or different user, what the user puts in or something like that. Make sure that you know these 3 data types. These are 3 really common ones that we have mentioned. An int is short for integer. That's a whole number. A float is a number that can contain a decimal. And then a string can be a letter, a word, a sentence, really any sequence of characters. And strings are going to be inside quotation marks. Know how the input command works. So what you have input, parentheses, your prompt goes inside the parentheses. What do you want to display on the screen to let the user know what kind of information you need in from them? And then it will read in their response. When the program is running, it will sit and wait for the user to type something in, and then it will read in their response and save it as a string. So if you want some sort of input that you can do math with, you have to cast the answer that they typed in as a number value. So that's the next thing here. Remember that input is read in as a string, and you can convert it to an int or a float if needed. You don't have to. It's, if it's something that you're going to need to have in a number format, you can do that. Know that a single equal sign is the assignment operator. Order does matter. You have to have, the expression over on the right-hand side. That gets evaluated first. And then whatever value it simplifies down to, it's stored in the destination is over here on the left. And so you do have to, you can't flip it. That would give you an error. So x equals 7 is good. 7 equals x is an error. So that's a little bit different from how we're used to, an equal sign to stand for these 2 things are equivalent. That's not how it is in computer science. The combined assignment statement allows you to do some sort of math and also take the result of that math and store it back in the variable. So if, for example, you had like X and it equals 3, and you said X plus equals 1, that says, take the value that's in X right now, take the 3, add 1, so now it'd be 4, and store the 4 back in the X, right? That's the big difference between doing plus equals as opposed to just plus by itself. X plus 1 would equal 4, and you could print that out, or you could use it, or you could store it in another variable, but that would not change what was stored inside of X, as opposed to a combined assignment statement would. Our mathematical operators, we can add, we can subtract, we can divide. The double divisions does integer division, which says that if you have whole numbers, you're going to divide and only keep the whole number portion of your answer. Do not round, just chop the decimal completely off. It won't even calculate it. So it doesn't matter if it's like 0.99, that does not like make the number round up because the computer will never even see it. This is multiplication. Double asterisks is for exponent. So it's the first number would be your base, and then you raise it to the power of the second number would be your exponent. So like 3 asterisk asterisk 2 would be like 3 raised to the power of 2, 3 squared, which would equal 9. And then the percent sign is the modulus operator. Mod says to divide the two numbers and return the remainder, not the quotient, not the answer of the division, the remainder that was left over. Just a couple of kind of practical applications that we do with that. You can use the mod operator, for example, to determine if a number is evenly divisible by another number. So if any given number mod 2 equals, remember we have to have double equal signs when we're checking for equality because one equal sign is the assignment operator. If I have some number, mod 2 equals 0, that would mean that if I divide by 2, there is no remainder at all. So it was evenly divisible. That would mean that the number was even, right? Or if you said like some number mod 10 equals 0, then you know that that number is divisible by 10. We can use like mod 10, mod 100, mod 1000 to chop off digits. Like if you had a longer number and you were trying to get just one single digit at a time, if you wanted like just the final one, you could use mod 10. So for example, let's say you had 13 mod 10. So if I said, what is 13 divided by 10? 10 could go into 13 one single time, right? You'd get the 10. And then what would you be left with? Well, 13 minus 10, the remainder would be 3. So you can kind of, visually see that if I took some 2-digit number and I divided it by 10, well, that's really just going to get rid of the first digit, right? What I would be left with would be whatever was in the ones place. So for example, 13 mod 10 is 3. I get what was in the ones place. So sometimes when you're dealing with large numbers and you want just like the last digit, or if you grab like a digit and then divide by 10, grab a digit, divide by 10. There are multiple different uses for the mod operator. It might not really feel intuitive. You might kind of be thinking like, what's the point of that? I promise you, I have used it in multiple programs and it actually was helpful, and you'd kind of be surprised sometimes at how helpful it can be. A Boolean expression is going to be something that can simplify down to either a true or a false. And we can have true and false, which are capitalized in Python. So those are going to be values. We have like a true could be like a 1 and a false could be like a 0. And if you had a Boolean expression that evaluated down to a number, 0 would be false and any non-zero number would be considered true. We can also combine logical operators together with like and, or, and not. And the way those work is for and to be true, they have to both be true, true and true to be true. For or to be true, you only need one. As long as one of them is true, you're good. So true or false, you're still good. False or true, you're still good. True or true, still good. And then not is a negator. It will take whatever you give it and it'll flip it. So not true is false, not false is true. Your conditional operators, sometimes also called relational operators, what you're comparing here is how two numbers compare to each other, or not even just numbers. You can use these conditional operators to compare words even, and you can use them to compare these Boolean values. Like I could say, you know, does true not equal true? And very confusingly, that would be false, right? Because true does equal true. So we can use them with numbers, but we can use them with other data types as well. So double equal signs is used for equality. Are the two things that I am comparing equal? In Python, you can use that even for like words. So I could say, you know, like, we saw that example in our programs where we let the user enter in some word and then we check to see if what they entered in equaled yes or equaled tent or, you know, something like that. So you can check to see if two things are equivalent, less than or equal to, greater than or equal to, and the exclamation mark means not. So this would mean not equal to. You will see conditional branches on the exam, but you will not see nested conditional branches. And you will also not see nested loops. I think there might be one or two questions where you could see a conditional statement inside of a loop, or vice versa, you could see a loop inside of a conditional statement or something like that, or like a function call inside of a loop or something like that. But you aren't going to see like an if, else, if, like multiple nested conditionals. That's not on there. And there's not like multiple like nested loops either. Okay. So an if statement is a standalone statement. The computer will look at it. If the conditional is true, then it'll run everything that's indented over. If that conditional is false, it'll just skip it and move on to the next line. And if else is a fork in the road, you force the computer to take one of two paths. So it'll look at this first if conditional. If it's true, it'll enter this branch and it will run these statements. And if this is false, it'll come over here to the else statement and it will run those statements instead. For an if, else statement, you can have as many if branches as you need. So you could have lots of different paths, like multiple different possible branches that you could go into, and they would all be chained together. So the computer would start at the very top and it would look at each conditional one at a time until it finds one that's true. And the first one that is true is the branch that the computer will enter, and it will run those statements, and then it will skip completely out of the entire block and like go down to the next line of code. So even if multiple branches would be true, the computer won't even look at the other ones. As soon as it finds one that works, it will run those lines and then break completely out of the block. Loops that we talked about were the while loop and the for loop, where the for loop uses that range function that we took a look at. There are three different ways that we could call range. We could say range n, which is going to give you 0 up to n, but not including it. We could call range with two numbers, which would say this is where I start and this is where I stop. Again, not including it. And we can call range with 3 numbers where we're giving it a start, a non-inclusive stop, and a step. Every time it updates, how far was the increment? You could almost think of that like the slope, you know, if you're kind of a math person and you're picturing, you know, what is the rate of change between each new number that I am considering? So a for loop is going to run a known number of iterations. You have a lot of control and you can exactly specify how many times a for loop runs, as opposed to a while loop where you might not know how many times it's going to run. If you asked the user, you know, you're going to make a receipt for them to check out at the grocery store, and you tell them to enter in the cost of the items, you know, that they bought one at a time. You don't know how many items everybody at the grocery store bought, right? Every single customer could come up to you with a different number of items. So you don't know in advance how many times that loop needs to run. That would be a good example, you know, to use a while loop. And you could take advantage of a sentinel in that case. So a sentinel value we talked about in the slides is a number that signals I am done, and you can break out of the loop. So you could tell, you know, the user, you know, enter the cost for each item and, you know, enter -1 when you're done. And then, because you're not going to have like a negative cost for an item, right? So that would not be a valid input. So then you could let the loop run as many times as necessary, and everybody that used your program could enter in the number that they needed. So make sure that you know what a loop control variable is. We used several different examples of these. I tended to use like X, but you don't have to. That's not special. It's not reserved. It's just kind of an example that I used often. And then know these examples here. So we talked about a counter and an accumulator. I did an example of each one of them in yesterday's video. A counter can just like count a number of items. And it's not always, the example I did was like counting the number of iterations that the loop ran. That's not the only thing that you would want to count, right? You could read in a list of words and you could count how many times some certain word was said, or how many of the words were capitalized, or you could read in a number of transactions and you could count how many of them were positive, you know, something like that. So a counter is going to have some variable to store your count. That variable should start at 0 because it may not ever happen. Don't necessarily start your counter at 1 because you could be looking for something that never happens. And so then, you know, you don't want to say it happened one time if it never did. So start your counter at 0. And then every time you find what you are looking for, you increment by 1. And you could use that like shorthand combined assignment operator to do that. You could say like variable plus equals 1. And that would just add 1 to your count each time you found the item you were looking for. An accumulator, on the other hand, is going to keep a running total of something, right? So every time it finds what it's looking for, it's going to take that value and add the value, not a 1, the value to the running total where you're adding all the numbers up. A sentinel I explained just a second ago. A sentinel is a value that signifies to the user or to the program, you can stop what you're doing. I've entered in all the items I want. And that is it. So just kind of overview of the exam. It's 20 questions long. There are 5 written response questions, 15 multiple choice questions, and there is a 1-hour time limit. There isn't one where you kind of like write a full program on this one, But there are several where, those written responses where you have to write, little pieces of code. So you could be asked to write a loop that, would run some certain number of times, or you could be asked to write a function that would, return some given value. And they'll be simple, they'll be short, but those are valid questions that could be asked. And a lot of the questions are going to be very similar to the questions you saw on the quizzes. So definitely go back and take a look at your quizzes. And if you missed questions or you aren't sure about like what you missed or how you did, reach out to me. We can pull it up. We can go through it. I would be happy to make sure that you feel good about those questions before you take your test. So I think that I'm just going to program like just one little example here in Python, and then we'll call this video good. I just always feel like we need a little bit more programming practice in this class because in a regular semester, we would be writing code examples in class every single day. So, I mean, you would be seeing this like, an hour and a half to 2 hours worth of examples every week, as opposed to, in the summer term where we've really haven't had quite as much programming practice as I would like for us to have had. And that's just for time's sake. So let's do an example of, let's do an accumulator and a counter. And let's do, use a sentinel value in a loop. And let's have a conditional inside of a loop, because those are all things that I think would be good for you to practice and see examples of before the exam. So let's start by saying, let's kind of think about what we're going to do for our program and plan it out a little bit, and then we'll write the code. So what we're going to do is we're going to let the user enter in values, and I'll do the example I said earlier, where we will add up all the money that they spent at the grocery store. So we'll just let them enter in their values one at a time until they're done. And then we will throw some tax on there and then tell them their total. Okay. So, and then to have a counter, we will, we'll ask them if their item is on sale. And if it is on sale, we'll give them a discount. Let's just make everything 10% because that'll make the math easy. And then we can count the number of items that they bought that were on sale. So that's a little bit of a more complicated program. You won't really see anything quite that complicated on the test, but it's good to have an example. I think this is a good example. So comments. Have a hashtag to make a comment. So at the top of your programs, you guys have been doing a really good job about having your comment heading blocks. That's nice. Well done. And then we'll say description. What is this program going to do? Let the user enter prices for items they buy at the store. If the item is on sale, we will take off a 10% discount. The program will also count the number of sale items. Beautiful. Okay. So let's, if I just asked the user, enter a price, enter a cost, that would be a good place to start because that's information that I am going to need from the user. However, if I do that and it's on a line all by itself, it's just one single line, that one question is going to print out one time. And what I really need is the ability to ask the user to enter in as many items as they need. And I know that's going to be a while loop because I don't know in advance how many times I want that loop to run. So let's think about what our conditional could be. How are we going to know our loop has ran enough times? We have all the information we need from the user and we can stop. So the user is entering in the information. We need the user to tell us when they are through. So we need a sentinel value. And the person entering in the prices needs to know what that sentinel value is. They need to know when they're done. So I'm going to tell them. So I'm going to just have some print statements here and let the user know how I want them to use the program. So you will, we don't need to say that. We'll just say enter a price for each item or enter -1 to quit. Actually, that could just be the prompt for my input statement, huh? So I am just going to go ahead and make this an input statement. And this can be what gets printed out to them. That would be fine. That would be, enough. I want to store their answer. So I'm going to say this is going to be like the item cost, right? And some of you are probably already realizing that because I'm going to be doing some math with this, entering in their answer as a string is not going to cut it. So let's go ahead and cast their response as a float. We have seen a lot of examples of casting numbers as integers. However, a price is traditionally going to have a decimal with it with 2 numbers after the decimal. So I think it makes more sense to cast a cost as a float. Okay. So now the user kind of knows what we want them to do. And we know that we want this to happen repeatedly inside of a loop. So I'm going to say as long as, and here is where I'm going to run into a little bit of a logic issue. If they enter in -1 to quit, the way my loop is going to know that it's done is if cost has a -1, right? So I'm going to say like, run this loop, check to see if they entered a -1. If I go back up and it's a -1, break out of the loop. So, okay, fine. I can say run as long as cost does not equal -1. And I have a problem here. They don't know what cost is, right? Cost doesn't exist anywhere because I set the value, I assigned what the value would be stored in cost down here after I'm using it on line 7. So here is something that would be a good example of why you might want to comment to explain what's happening in your code as a programmer. So I can say, define the loop control variable cost. And as long as it does not equal -1 up here, then my loop will go ahead and run, and it can come down here and redefine. It'll put a new value in it after I run the loop, because the value that is stored inside of a variable can be overwritten, right? And then I'm just going to update it because my computer's lagging a little bit, and that's why it's not recognizing that that I did define cost above it. Okay, so now because we have defined that cost is 0, as long as you don't set it equal to -1, then you will enter into the loop, and they can come down here and they can enter their own price as many times as you want it to happen. Now, there are a few other things that we need here, right? If I'm going to know what someone's total bill is, then I need to add up all of the costs that they enter. This number is going to get overwritten every time they enter in some new value. Every time this loop runs and they enter in a new price, it's going to get stored in cost. So I'm not saving the values that are being put in cost anywhere. It has a value, but then it gets overwritten and it gets overwritten and it gets overwritten, and we lose the data that was there before. So what we need, and actually we should just say define the variables, because we're going to need multiple ones, aren't we? Because we need an accumulator. We need some place to store adding up all of the costs that they enter in. So we'll say, and every time they enter in a new cost, we're going to take the value that was in total and we will add the new cost that they entered. And notice we use that combined assignment operator. Take the value that was in there, add the new cost, and then store it back in there. So then we'll keep our running total, our accumulator, in our variable total. One other thing that we said we were going to do was have a conditional inside our loop. So we're going to ask the user if the item is on sale. And if the item is on sale, we're going to do two things. We are going to discount the cost by 10%, and we are going to count the number of sale items. So let's go ahead and create a variable for our counter. And I'm going to call it number of sale items. And that will initially start at 0. Because what if they bought nothing that was on sale, right? I want my counter to start at 0 because in the beginning, we assume that we don't know if there are going to be any items or not. Also, if I'm going to take 10% off of the cost, I need to do that before I add that cost to my running total, right? I'm not taking 10% off the entire total, bill. I'm only taking 10% off of the cost of the one single item that they just entered in. So when we think about like flow of control and the order of execution, we want to know if we should take that 10% off here, right? I just kind of like inserted some empty lines so that I could put that command here before we go ahead and add that to our total. So we're going to have a, and I'm going to throw some comments in here to explain what's happening too. So we're going to say loop to let user enter the price of each item. And so we get their cost, and then what do I want to do? I want to ask user if the item is on sale. If it is, discount 10% and count. So that's what we're going to do. So first, I will ask the user. So we need a prompt there. So this is going to be a Boolean value that will be, we'll call it on sale is going to equal, I need to ask the user, is the item on sale? So this will print out as the prompt. I will read in their answer and I will store it inside on sale. So we'll say if on sale. And we can say if that equals yes. And if we wanted to be like really fancy, we could say like or on sale equals yes. And that way, if this is true or if this is true, then either one of them is going to say true. So like basically I'm saying they're both yes, whether they capitalized it or not. Another way that you can kind of do this is you can use a command, to just make everything in the response like lowercase, for example. And then all you would have to do is just test for this one, and it doesn't matter how they typed in their answer. So that would be like input sanitation. Basically, I want to take whatever the user gave me and I want to kind of manipulate it and clean it up a little bit so that I know that it will run correctly for my code, regardless of how they entered in their answer. So if the item is on sale, what do I want to do? Well, first of all, I will discount the price. So their price would equal, let's just do a combined assignment operator. Take whatever the original price was and multiply it by 0.9. 90% of the original price would be 10% off. And then also the number of sale items can be incremented by 1. So let's take a look at the indentation for this program. Everything here is indented over at least one time because I want this to happen every single time the user enters in a new cost. Every time they give me a new item, I need to know, is the item on sale? And I need to add it to my total, right? Here, where I say what I want to be part of this conditional statement, if the item is on sale, then give them a 10% discount and count the number of sale items. These lines right here on line 19 and 20 have been indented twice. Once to make it part of the while loop and a second time to make it part of the conditional. So these, you can kind of see the gray lines a little bit where that has been indented twice. So this is an example of a conditional inside of a loop. Okay. And that's everything that we said we would do. We have a sentinel that allows the user to enter in prices. We let them quit when they are done. We ask if the item is on sale. We have a conditional to discount it and count it. And we keep track of the running total. So we have an accumulator. So then finally, I will break out of this loop entirely and I will print out their final results. So we will say print your total bill is, and then we will say that's going to be their total. And then we will say you purchased, and then that would be number of sale items on sale. So enter a price for each item or enter -1 to quit. And we're going to make the math really easy on ourselves. We're going to make some like $10 things. So this was $10. Is it on sale? No. And then $10. Is it on sale? No. So far we've spent 20 bucks. And then we're going to do one more. So it was $10 and this was on sale and now I'm done. So we should have spent $20 here and then $9 here. So our total should be 29 bucks. Oh, I didn't calculate the tax, but that's okay because we did some other things that use the assignment operator. So that's fine. The combined assignment operator. So that's fine. And so we should have a total of 29 bucks and one item that we purchased on sale. So we'll see if our program was correct. Oh, and that's a really good point. If I enter -1 to quit, it's going to continue to do everything that's in this loop before it breaks back up here to check to see if our loop should continue or not. So that's why it's asking me, is the item on sale? Even though I typed in -1, the computer really isn't even checking to see if I entered in -1 until I get back up here to check the condition and see if it's finished. And that's going to be a problem we can just go ahead and say, no, the item's not on sale. That isn't really a big deal. The problem is right here where we add the cost to total. When we entered in -1 to quit, it's reading in that -1 as a cost. We could, go through and kind of clean this up a little bit, but for the sake of this video, this is kind of just meant to be a quick example. We're going to cheat just a little bit, take a bit of a shortcut here, and I'm just going to go back into total and just add back in the one that I took out for cost. And that'll fix it, just sort of for this video sake. So we'll enter in the same thing, a $10 item, not on sale, a $10 item, not on sale, a $10 item that is on sale, and then we'll quit. All right. So we get a correct final answer now. And you can kind of see when you start doing, things like that, why you really need comments. Because if somebody else came and looked at our code and, they maybe didn't recognize that at first, they could be like, well, why are you just adding money onto the customer's bill? You guys are trying to cheat your customers. So it could be really helpful to have comments, to explain what's happening, and that can make your code a lot more readable. And not only just like for other people, even for yourself too, because you can forget, why you had to add things like that in there. So, we could just put in here, add the -1 back in that from the cost to quit. From the cost and treatment. And this program right here is going to be more complicated than anything that you will see on the exam, but I do think it gives you a good example of all of the different kind of combines together a lot of things that you might see. So if you feel good about using a Sentinel to break out of a loop, if you feel good about having like a conditional inside of a loop, if you feel good about using the combined assignment operator, if you feel good about the logic to have a counter as opposed to the logic to have an accumulator, and if you feel good about the ability to print out strings and combine them with variables as well, then I think you are well prepared for the test and you can go ahead with it, and good luck. If you kind of feel like you would like some more examples or practice with this, by all means, email me. I'd be happy to meet with you. I have the Zoom calls, but people don't really show up. So if a different time is better for you, you can just email me and I would be happy to meet with you at a time that's more convenient. So good luck to everybody on exam 2. And a reminder that I am going to push back the slides. They will be due next Sunday. Go ahead and start on them though this weekend, because you have assignments next week as well. So, be careful that it's a lot to manage. So be careful that you're kind of, managing your time well. And good luck. I will see you guys in week 5.